Solving matrix equations. So this is a matrix equation. This matrix times this matrix with two unknowns is this answer matrix. Sometimes they will give a matrix equation like this. Find x and y in matrix X if A times x equals B. This matrix times this matrix equals this matrix. Now you can see that this would work. That times that gives you 25, added together gives you 25. That times that, added together gives you 26. But we need to find these numbers. And so, if you think about a normal mathematical equation, don't bother writing this down. Remember, if you're solving equations, you've got to look at your unknown and get it on its own by doing the opposite of what was done to it. X times 3 is 12. I needed to divide by 3 on both sides because times 3 divided by 3 cancels out, leaving me with x is 12 divided by 3, x is 4. I need to do the opposite of whatever was done to x on both sides to cancel out on the unknown side, to leave the unknown on its own, and get the answer on the other side. And that's exactly what we do here. This times the unknown is our answer. But I can't just go, okay, I'll divide by this. I need to do the opposite of multiplying by this matrix, which is multiplying by the inverse. So the rule is multiply both sides by the inverse of the matrix that's hanging out with the unknown to get x on its own. And then, of course, we calculate. Now, there's one thing that's a tiny bit more complicated. Here we've got a times x equals b, but in the next set of problems, we'll have x times a equals b. And we know that order of matrix multiplication matters. So, if it's ax equals b, we do what is calling pre-multiplying, that is, multiply at the start. We pre-multiply by inverse of a to get rid of a on both sides. That means it's going to go in front of the a here, inverse a times ax equals, and in front of the b, inverse a times b. I'll go through how to do this. These are the rules. Inverse a times a cancels out to the identity matrix, which is just I. It goes away. And so we'll get x by calculating inverse a times b, which we'll do in our graphics calculator. For the other way around, xa equals b, so when a is second, we'll post-multiply. We'll multiply afterwards. We want to get rid of matrix A, so a matrix X is on its own. Post-multiply by inverse A. So that will be, we multiply after what we've got. Here we multiplied before everything. Here we're going to multiply after both things. So I've got XA post-multiply by inverse A, so they're next to each other, so they'll cancel, equals B post-multiply, by inverse A. A times inverse A will cancel, leaving me with matrix X is B times inverse A. And we'll do that on our graphics calculator. So those are the rules. Let's have a look at how we apply them. Find matrix X from this above question. AX equals B. Please be aware, I do not need you to write the matrices out like this. They've told you AX equals B. They've told you what AX and B are. I can just start by writing AX equals B from the question, AX equals B. A comes first, so I'm going to pre-multiply by inverse A. Next line down, inverse A times AX equals, pre-multiply, inverse A times B. So, matrix A is first, pre-multiply. Then, cancel inverse A times A on the side where the X is. That's the whole point of doing this. Rewrite it. Matrix X is inverse A times B. Use your graphics calculator. Get A and B into the graphics calculator. Edit. Quit out. Go to edit. We'll want this one in matrix B. This is a 2 by 1 matrix. Hop back out. I need to do inverse A times B. Matrix menu, choose matrix A, make it inverse with just the X to the -1 button, times, I want matrix B, select matrix B. Inverse A times B, and it's found my answer matrix, and you write X equals the answer matrix. Or you can write X Y in a matrix like that equals 5, 2. Either of those ways of putting your answer are fine. That's the working you need. You do not need to write the matrices out. You work with the matrix equation with the letters. Another example. They've given me A and B. Find X if XA equals B. This is, A is second. We're post-multiplying by inverse A. We've got the equation, XA equals B. Post-multiply by inverse A. XA times inverse A equals, post-multiply by inverse A on this side. B times inverse A. Cancel A times inverse A on the side where the X is. Rewrite what you've got. X is B times inverse A. Use your graphics calculator. Get B and A into your graphics calculator. Now I think I did, but you can see it can get quite confusing when you've got other matrices. I already had A and B being used. I've put them in C and D. So this is matrix C. This is matrix D in my graphics calculator. But that's likely to set me up to fail. In a test, or if it's really critical, delete your previous matrices and use matrix A and matrix B if that's how it's going to go, because you don't want to mess up. I need to do matrix B first. Select matrix that you entered in as B times inverse A. I put it in as C, but if that's going to confuse people, so remember you've got to get C, make it inverse. If it would confuse you, delete your other matrices, enter it in. Get your answer matrix. And we're done. We can use this to solve simultaneous equations. If you're finding that that's enough to think about, you could stop at this point, go and do the exercise, come back and learn how to do simultaneous equations. I've put them in one video, you might like to treat it as two. So you remember solving simultaneous equations is we want to find an answer for x and y that's true for both of these rules. And we've learned how to do it before using algebra. We can do it with matrices. The steps that you follow. Write the equations. With the x's and the y's aligned. And what that means is the x's, the y's, the equal, and the answers all have to line up. Sometimes you might need to rearrange an equation to be able to do this. It has to line up. I'll show you what I mean when we get down here. And then we write this in matrix form. And I'll show you how. Now, we're going to put it into a matrix equation in the form AX equals B, and we get it I know I'm being confusing with colours here. I'll show you how it works. We write our equations lining up, and I've put the numbers in different colour because this will become matrix A with A, B, C, D. The numbers from in front of the x and y in both equations times matrix X will be the x and the y, x then y, row, column, equals matrix B, E and F, the answers to the simultaneous equations. Bit tricky, it'll make sense as we do the example. Write our equations with x and y aligned. Write them in matrix form, AX equals B. So, the numbers in front of x and y go in the A matrix. There's no number in front of y, but I've got negative, so it's negative 1. If it was plus, it would be just 1. That's my matrix A. Matrix X is x, y, equals matrix B is the answers. And now I've got a lovely pair or set of matrix equations that I can use to solve these simultaneous equations. We solve them the way we would do that. Now I'm going to call these matrix E and F. E times X equals F because I've entered them into matrix spot E and F. If you didn't like that, you clear all your other matrices, but sometimes you'll get different letters. So I write E, X equals F. E comes first, so I pre-multiply by inverse E. Pre-multiply by inverse E on this side. Cancel inverse E times E. X equals inverse E times F. X equals, enter them into your graphics calculator. Then I need E inverse, oops, that's not inverse. Inverse, that didn't work. Matrix E inverse times matrix F, I have 5, negative 1. And because this was a solution to these simultaneous equations, we say, therefore, x equals 5, y equals negative 1, because we were finding x and y.